Hey everyone, welcome back to Ruijie RCNA class. I am Nick Xia. We had a brief study of IPv4 addresses before. Today, we need to talk about more, the classification and aggregation of IPv4 addresses. Tom had finished a lot of tasks, and today he received a new project. In this topology, we can find that these two departments, it has this IP address, and these two departments has this IP address. But Tom finds that it's very strange because he never see this 24 mask before. So, what's the difference between it? We learned the class of the IPv4 address before. We know it has 5 classes, class A, B, C, D, and E. Do you remember the difference between them? You can review our former course. And this classification, it was simple and effective. But now, the class 4 classification fixed the network scale and the width of IP addresses. Think about it. Every time for the class C IP address, we can only use the 24 mask. But if we have a smaller network, we will waste half of the IP address. So the VLSM, variable length subnet mask, is used to classify the subnets into smaller network. Of course, we can also divide this subnet to more smaller subnets again. Then CIDR is used to reduce the routing entries. This is because when we use 24 mask, we have 2 routes. Then we can combine them together to a 23 route. It can reduce the routing entries. Okay, so now let us have a summary. The VLSM is have to divide the big network into smaller network, and the CIDR is used to reduce the routing entries. Okay, they are different. For the subnet mask, here is the example. Normally we write them using the decimal mode, but for computer we need to translate them into binary mode. It has the 0 and 1, 2 bits. And for the mask is composed of consecutive. The former all of which is 1, and the latter all of which is 0. The former is for the network and the latter is for the host. So here we have example 10112. The mask display here. So we can find that the 30 bits is for the network and the last 2 bits for the host. So 2 bits for the host, we can have 5 combination. Okay, 0, 0, 0, 1, 1, 0, and 1, 1. It means we have 4 IP addresses in this subnet. Okay, here another example. 192.168.10.213. Okay, translate it. Then translate the mask. This time we can find that it's not a 24 mask. So it's not a normal class C. In fact, it uses VLSM to divide it into a smaller network again. So we can see that these 2 bits is for the hosts before, now it's for the network. So we can have 2 to the power 2 equals 4 subnets. And for the host, we only have 2 to the power 6. Okay, 8 minus 2 is 6. Then we also need to minus 2 because the first IP address is for the network ID and the last IP address is for the broadcast. Then we have 62 IP addresses are available for the PCs. Now we can write them into 4 subnets. Here another example. I recommend you to use stop button and then write it by yourself first. Now, if you have finished it, we can talk about it again. This time, the subnet, the mask is 23. It means we borrow 1 bit from the network to the host. So this time, how many hosts can be used? 2 to the power 9. 8 as 1 equals 9, and then minus 2 equals 510. Okay. Now let us have a summary. Today we learn the classification and aggregation of IPv4 addresses, and we know before it we learn the class A, B, C, D, E, and then it's not enough. So we have new technology VLSM and CIDR. They are different. Then we use several examples to calculate how many subnets and how many hosts. So I also leave you several exercises again. Please read and answer it. Thank you for watching this video. See you next time.